The Constitution of India, Preamble. We, the people of India, having solemnly resolved to constitute India into a sovereign, socialist, secular, democratic republic and to secure to all its citizens justice, social, economic and political, liberty of thought, expression, belief, faith and worship, equality of status and of opportunity, and to promote among them all fraternity, assuring the dignity of the individual and the unity and integrity of the nation. In our Constituent Assembly, this 26th day of November 1949, do hereby adopt, enact and give to ourselves this Constitution.
Happy morning, students. I know you all would have watched the video of our Gurukala, Disney Gurukala, our youth festival for 2020 and 21. In the history of any school conducting a youth festival, this is the first time a school conducting youth festival on a virtual platform. Adding feathers to the cap, we had great legends who had come as a chief guest. So I hope you would have all watched it live, sitting at your own comfort. So share it with the maximum friends and relatives, children, so that this should reach out of the world, like should reach the entire universe, because these coming 9 days are very important for us, as the youth festival is going to be for another 9 days. So, and it is going to come out as a grand festival only with the support of parents, teachers and students, right? So teachers are expecting great participation from the students, and I know my children will also be a part of this. Have a great time, give your best, give the 100% of yourself, so that participation is winning, which is the most important factor, I would rather say. Okay, now getting into academics, we were discussing about in last class properties of cathode rays and canal rays, and also charge to mass ratio, all those things, right? Today we are going to see atomic models, that is different scientists who have given about atom, its structure and how the electrons are present inside. The first one which we are going to see today is Thomson's model of atom. Thomson, he in 1898, he was very clear that there must be an atom which is spherical in shape, which is round, like a sphere. It is spherical in shape and which has got a positive charge distributed uniformly, which means the sphere is completely of a positive charge, a sphere with positive charge. And he said there are electrons which are embedded into it. Embedded means which are put into it, pasted in it. There are electrons which are put into in different places of the sphere. And he was referring that to a plum pudding, or I would say raisin pudding, or a watermelon. Because in watermelon, you know, you have a green ball inside a red flesh with black seeds. So he was referring the whole watermelon as an atom with positive sphere, and the seeds as the electrons which are placed here and there in the atom. So this is what was given by Thomson. So what he was concluding after he was making all the research was that mass of the atom is uniformly distributed. The mass of the atom, when I say an atom, its mass is being uniformly distributed throughout the sphere. It is not concentrated only at one part of the sphere. That was the conclusion made by Thomson. But Thomson was also not able to clarify certain things which was still a question mark, like the stability or how far the atom is structured. So he was only referring to atom as a spherical sphere with positive charge and electrons embedded into it. So now further Thomson's experiment was developed by Rutherford with a gold foil experiment, which we will be seeing now.
Thomson's atomic model. Joseph John Thomson, a British physicist, discovered the electron in 1897. When he passed an electric current through gases at low pressure in a cathode ray tube. Thomson used glass tubes fitted with two metal plates called electrodes at both ends. When the electrodes are connected to the source of electricity, a glowing beam called a cathode ray traveled from the negative cathode to the positive anode. When electrically charged plates were brought near the path of the ray, the positively charged plate attracted the cathode ray, while the negatively charged plate repelled it. A similar deflection was observed when a magnet was brought towards the cathode ray. Thomson hypothesized that the cathode ray was a stream of negatively charged particles which he called corpuscles. They were later named electrons. Thomson introduced a model of the atom in 1904. According to his theory, an atom is a sphere with positively charged particles surrounded by negatively charged electrons. He also suggested that positive charges are equal to negative charges. The model was referred to as the plum pudding model because one could imagine a plum pudding wherein the pudding itself is positively charged and the plums dotting the dough are the negatively charged electrons. This plum pudding model of the atoms suggested by Thomson was later proven incorrect by Ernest Rutherford, when he showed that the positive charge is concentrated in the nucleus of the atom. Summary: J. Thomson proposed a plum pudding model of an atom. He suggested that the atom is a positively charged sphere in which electrons are randomly distributed.
To see Rutherford's nuclear model of atom. In Thomson, we were telling it was just like a sphere and you had electrons embedded into the positive sphere. But what is Rutherford nuclear model of atom is saying that he did an experiment through alpha scattering. That is, alpha being positive rays, he made a source to send these alpha particles from the source passing through the lead plate, hit on the gold foil and then marking at different points of a photographic plate. Why do we take a photographic plate made of zinc sulfide? So that when it passes through the gold foil and hit the photographic plate, you can see a spark or a dark spot, a marking where the deflection has happened. According to this experiment, when a stream of alpha particles is being sent through the source and when it hits the gold foil, it passes through the foil and hit at the various places in the photographic plate. But according to Thomson's model, he says when I take a gold foil, atom is uniformly distributed, which means the alpha particles will have enough space to pass through the gold foil to get deflected. But that was not happening. What was the observation after this experiment? Most of the alpha particles were remaining undeflected. What do you mean by deflected? Changing the direction. They should have some space to change the direction, that is called as deflection. But here when the experiment was done, it was understood that most of the alpha particles were not getting deflected. And then he said only a small fraction of alpha particles were deflected. Say out of 100, hardly 20 or 30 were deflected properly at a small angles. Then what happened? Very few bounced back. That is, after hitting the end, they came back again. That is called as bouncing back. Some were passing through, some were not passing through, some were not getting deflected, some could get deflected to very small angle, but some after going they bounced back again with a linear angle of 180 degree. These were the observations after the experiment was done. So once these observations were seen during the experiment, he drew some conclusions. He was very sure that this must be the property of the nuclear model of atom. So now let us see what are the conclusions and the postulates of nuclear atomic model by Rutherford. We were seeing the observations of Rutherford experiment, what was happening. when a stream of alpha particles were hitting the gold foil. Now these were the conclusions. Conclusions means after the experiment is done, these were the things that he has found out. What was those? He said most space in the atom was empty. See, this is an atom which is in the form of a sphere. So when a stream of particles is hitting, there are spaces which are empty. Most of the spaces were blank. That's why there were no movement of the alpha particles. They were not getting deflected. So he said most of the space in the atom was empty. Then he said there were few positive alpha particles which deflected due to repulsive force. Children, when does the repulsion takes place? We know when like charges meet, they repel each other. When unlike charges meet, they attract each other. So when alpha particles which is positive in charge, when it comes and hit a positive center, definitely it has to repel, right? If it is going to be an electron that is which is negative, then it will pass through because it will attract. So he said positive charge is not uniform because Thomson model was the positive charge was uniform throughout the sphere of an atom. But what Rutherford is telling, if this is my alpha particle, if it hits a positive center, it will get repelled, otherwise it can pass through, right? If it is, so not all the place is positive, that's why he says repulsion is happening for few alpha particles, which means there are positive charges here and there in the atom, not all over the atom. Then next he said volume of the nucleus is small as compared to that of the volume of the atom. So this is my atom and I have my nucleus. So this volume, what does the volume means? Space occupied by the substance. So the volume of the nucleus is negligibly small, which means it's very small as compared to that of the volume of the atom. When I take an atom, it has nucleus, protons, neutrons, electrons. When I take nucleus, it is very small as compared to that of the total volume of the atom. So these were the conclusions. So he said most of the space in the atom was empty and there are few positive alpha particles which were getting repelled because there were positive charges not uniformly distributed, and he also told the volume of the nucleus is negligibly small as compared to the total volume of the atom. So what are the postulates? After drawing the conclusions, he was able to give a theory for the nuclear model of the atom. He was able to find out that there is something called nucleus in an atom. What was that? He said there is a positive charge and most of the mass present or concentrated put in a very small region, and that region is called as nucleus. That is how he gave the name for the nucleus of an atom. So how did he say? Nucleus is something which has got a positive charge and the entire mass is concentrated on that small region, which we call it as a nucleus. And then he said around the nucleus, it is surrounded by electrons which are revolving or circulating in a circular path. I have my nucleus and I have electrons which are moving in a circular path, which are called as orbits. Just like there is a sun in the solar system which is being rotated or revolved by the planets of the solar system. So my planets are my electrons and my sun is the nucleus, right? And then the last he said electrons being negatively charged, nucleus being positively charged, there is an electrostatic force of attraction. Positive charge, negative charge, there is an electrostatic force of attraction between the nucleus and the electrons in the atom, or which is surrounding the nucleus in a circular path. So these were the postulates of the Rutherford's nuclear model of atom. Children, these are very important. They may ask you for 2 marks in the board exam. Now we will get back into a familiar topic, what are atomic numbers, mass numbers, and we'll also see about isotopes and isobars.
Rutherford's scattering experiment. Thomson's atomic model is the simplest model of an atom showing the arrangement of electrons and protons. In this model, the positive charge of an atom is evenly distributed in a sphere and the negative electrons are embedded in it. It is also called the plum pudding model. In the year 1911, Ernest Rutherford, along with Hans Geiger and Ernest Marsden, conducted a series of experiments with the aim of exploring the structure of an atom. These experiments were called Rutherford's scattering experiments. The experimental setup consisted of a piece of radium, which is a radioactive metal, placed in a lead block. The lead block had a slit to allow only a narrow beam of alpha particles emitted by the radioactive radium to pass through. The alpha particles escaping from the narrow slit were directed to a thin gold foil of a thickness of approximately 100 nanometers. A movable circular screen coated with zinc sulfide was placed around the gold foil. The alpha particles produced by the radium escaped through the slit, struck the gold foil and got scattered. The scattered alpha particles were detected by the zinc sulfide screen in the form of light flashes or scintillations. Different portions of the screen were then examined to determine the deflection pattern of the alpha particles. It was observed that most of the alpha particles remained undeflected and passed through the foil. A few alpha particles got deflected through small angles, and hardly any alpha particles got deflected through large angles or came back with a deflection of 180 degrees. These observations did not hold true to Thomsons' atomic model, where it was expected that the positively charged alpha particles would pass through the weak electric field largely undeflected or slightly deflected. Thomson's atomic model was discarded since it failed to explain Rutherford's observations. Based on the observations, Rutherford concluded that there must be a large empty space within the atom, since most of the alpha particles passed through the gold foil without any deflection. Some alpha particles are deflected to certain angles, which means there is a heavy positively charged mass present in the atom. This positive mass must be concentrated in a very small space within the atom, since only a few alpha particles showed large deflections. The bouncing back of very few alpha particles with a deflection of 180 degrees indicated a direct collision with the positively charged mass of the atom. Later, Rutherford termed this positively charged mass as the nucleus and proposed it to be located at the center of the atom. Let's quickly summarize the observations and conclusions of Rutherford's scattering experiment.
We have already studied about atomic number, mass number, isotopes and isobars when we were in 9th and 10th standard, children. Atomic number is something which is equal to number of protons or number of electrons in a neutral atom, right? If how many number of electrons are there, that represents the atomic number. or atomic number will be equal to the number of protons inside the nucleus or number of electrons rotating in the around the nucleus. What is mass number? Mass number is the sum of protons and neutrons in the nucleus of an atom, right? The total number of protons and neutrons will be giving us the mass number, that is atomic mass of an element. Now what are isobar and isotope? If you see this example N714, that is nitrogen with atomic number 7, mass number 14, carbon with atomic number 6, mass number 14. If you see, the mass number is same for both the elements. So such elements which has got same mass number but different atomic number, we call them as isobars. Any element X, we denote the atomic number on the left side and of that is the subscript, and the mass number as a superscript on the left side of the element. So when the atomic mass is same, when the mass number is same and the atomic numbers are different, we call them as isobars. And out of isotopes, the atomic number will be the same but the mass number will be different. Here it is hydrogen, deuterium, tritium, that is you can see H11, H12, H13, all the three having the same atomic number but different mass number. So those we call it as isotopes. You can also take C613 and C614, also has got that called as isotopes. Now there is a question given to you in the textbook, bromine with atomic number 35 and mass number 80. Find out the number of protons, electrons and neutrons. So what is given in the question? Atomic number equal to 35, mass number is equal to 80. So we know atomic number will be equal to number of protons and number of electrons. So number of protons which is equal to my number of electrons which is equal to 35. Now how do I find the number of neutrons? We know mass number is equal to number of protons plus number of neutrons. So number of neutrons will be equal to mass number minus number of protons. So what is my mass number here? 80. 80 minus 35, which is number of protons, will be giving me the number of neutrons, which is 45. So this element bromine has got 35 protons, 35 electrons and 45 neutrons. The next question given to you in the textbook is the number of electrons is 18, protons is 16 and neutrons is also 16. Find the element, proper notation of the element. How can we do that? See, we know children, number of protons is equal to number of electrons equal to atomic number. But here protons is 16 and electrons is 18. But when I say number of protons is definitely equal to atomic number, so I know my element's atomic number is 16. And what is the neutrons? 16 again. And I know number of protons plus number of neutrons is equal to my mass number. So 16 plus 16 will be equal to 32. So the element X has got 16 as the atomic number, 32 as the mass number. But the number of electrons is 18, which is 2 electrons in excess, which means the element has gained 2 electrons. So how do we do? When an element loses electron, you put positive charge. When it gains electron, you put negative charge. So 2 electrons or more, so I put 2 minus. And what is my X? Atomic number 16 is sulfur. So sulfur 16, 32 with 2 minus. Like this you will get questions in your exam for your understanding. Okay children. So I hope you got an idea now. Now we will just have some drawbacks of Rutherford atomic model to understand why it got a failure, why it was not able to give a clear idea of the atomic structure. Why there are many scientists who are coming again and again with new models or new structures of atom is just because the previous scientists were able to do something but they were not able to account for the complete information about an atom. There might be few drawbacks or few failures which were disadvantages of that particular theory. That's why one more theory emerges out. So Rutherford, after doing this gold foil experiment, finding out the nucleus, this is, region with small concentrated mass, all those, but he had some drawbacks. Why? Because when he was comparing it with solar system, he said it was having a Coulomb force, that is being nucleus being the sun, electrons revolving around, the radius of the, like if I have a nucleus here and these are my orbits, this is the radius. That is how he was comparing with G m1 m2 by r square. That is our gravitational constant which you will be studying in physics. But that was a complete wrong statement given by Rutherford, because he was not able to account for the energy of the electron. See, when I say there is a solar system or planets revolving around, the planets gain some energy, there will be some radiations that are given out. Similarly, the electrons, when it is revolving around the nucleus, it gains some sort of energy, it gets excited. That's why this losing or gaining of electron actually take place in an atom. So, when this electron gets energy, what is actually happening? It is emitting radiation in the form of energy, and that radiation we call it as electromagnetic radiation. And what happens as soon as it is emitting the radiation, actually the orbit will start shrinking. The number of electrons getting excited more and more, the orbits will start shrinking. So what happened? This Rutherford's experiment was not giving us a clear idea about the stability of the atom. He was not able to tell us how this atom is more stable, or he was not able to tell us about the motion of the electron, how the electron are moving around the nucleus. It was a big failure, and he was not able to even say that the electrons are, whether it is stationary or it is on a continuous moving process. What have we learnt? We have learnt that electrons move continuously, they keep on moving. Imagine children, if the electrons are stationary, what will happen? Electrons being negatively charged, nucleus being positively charged, the nucleus will start pulling the electron towards itself. So what happens? The shrinking takes place. The whole size of the atom will start becoming a plum pudding, just like our Thomsons model, watermelon, raisin pudding, right? So he was not able to give all these three informations properly. That's why we started the Bohr's model of atom, which is going to give us complete information about the quantum mechanics, classical mechanics, dual nature of the atom and every other thing. So this I will stop for today. I will be putting you videos with respect to the topics that are being taken today. Watch the videos, take down the notes. When I am taking the class only, you can take running notes, and if you have any doubts, please don't fail to ask me, children. We'll get back into Bohr's atomic model in the next class. Thank you, children.